Welcome. This question says three equal positive charges lay at the points indicated in the diagram. The electric field at any point that is 2 meters away from an individual charge is 6 newtons per coulomb. What is the magnitude and direction of the electric field at point Z? So if I look at my diagram, I have one positive charge, which is X. I have another positive charge, which is W. I have another positive charge, which is Y. And then I have a point of interest, and the point of interest I'm going to just designate like that, and I'm going to call it P. And for information's sake, I tell you that the electric field at any point that is 2 meters away from any individual charge is 6 newtons. Well, this is 2 meters, which means this is 2 meters. Well, this is 2 meters. So if I do from X to P, it's a positive X, so P will go in that direction, and that's going to be 6 newtons per coulomb. And then from P, 2 meters away is Y, which is also positive. So this here will be 6 newtons per coulomb. And then from point W, there's point P, 2 meters away. And so that is also 6 newtons per coulomb. Fair enough. I want to make some headway. I have to break these vectors up into components. So if I think about my vertical components to begin with, the vertical component for this force, for this electric field, I'm going to draw it in, would be, well, we need an angle, don't we? The nice thing about equilateral triangles is all the angles are 60, and that means that this angle here is 60, and so if I think about it, that angle there is 60. So transferring across, this is 60 degrees, and this is 60 degrees. So this is going to be 6 sine 60 newtons per coulomb. It's going to point in the positive direction. But you know what, down here I have an electric field component, and that is going to be minus 6 sine 60 newtons per coulomb. And whatever they are, they're going to cancel each other out. There's no component, no vertical component for the 6 newton that's horizontal, so these two guys are just going to cancel. And then if I go and look at this horizontal component, this guy here is going to be 6 cosine 60. It's going to be positive newtons per coulomb. And then by the same token, I'm going to have the horizontal component of this force, this electric field here, which will be 6 cosine 60 newtons per coulomb as well. So that's 1, 2, 3 electric field vectors pointing to the right. So I can say, oh, and my electric field will equal, well, 6 cosine 60 is 3, and 6 cosine 60 is 3, 2 3s are 6, plus a 6 makes 12. It's going to be 12 newtons per coulomb, and it's clearly pointing to the right. So this is reminiscent of the problem we did using electric forces, but notice that it's sufficiently similar that it's confusing, but it's different. The question, which is earlier in the series about forces, had 4 forces and they were geometrically arranged, and this one only had 4 charges and they were geometrically arranged, and this question has 3 charges which are geometrically arranged at a point of interest rather than the 4th charge. But it's testing you on vectors, it's testing you on Do you feel comfortable with electric fields? I could change one of these to a negative charge rather than a positive, and then change the direction of one of these guys. It's a very versatile question. So there we have it.